Hi, now I'm going to introduce you to the concepts of input output stream. Okay, input output stream. So, uh, what is an input output stream? Any of your Java application is actually going to work with the input. Okay, you need to input some information. Okay, you're going to work with the input. Then after input, you're going to store it into a variable. Okay, then you're going to process it. Then you may do the output. Okay, input, store, and outputs. Okay, you process, you need the data, and also you may change the data as well. Not you store. And when you store, you're going to use variable data types or some complicated data store types. Or when you process, you may use normal sequential constructs, or you can use loop constructs, or you can use so on and so forth. Lots of things for you. And in computers, you often work with you often work with data and all kinds of data in form of bits or 0 1 1 0 0 1 1 0 0 0 1 1 1 or 0 so on and so forth. Okay, and and inside your computer is actually the smallest workable units of data is in form of bytes or 8 bits 1 2 3 4 5 6 7 8. Okay, this one is 1 byte so on and so forth. Yeah, but 2 4 6 8 another byte so on and so forth there. Okay, so on and so forth there. So 8 bits is a byte. Normally we work with a byte. Okay, for humans things we see something like a letter A, okay, or you see a number 10. Okay, however for computers they see only 0 and 1. So there's supposed to be a way for computer to represent a letter in forms of bytes or a numbers in forms of bytes. Okay, and let's say a normal letter is represented using ASCII standards, okay, or complicated letters or Unicode letters. Let's say this Vietnamese letter with a head on top is represented using Unicode. This Unicode is using 2 bytes, and this ASCII is using 1 byte. Or your letter A is represented using 1 byte, 8 bits like this. Okay, or this one, your letter is represented by 2 bytes, okay, or 16 bits. And number 10 is an integer. It is going to be represented by 4 bytes, okay, 4 bytes. Okay, yeah, those are some of the things about information representation. And then now, when you input, you're going to input data. Okay, and your data may be in forms of bytes, or maybe in forms of letters, okay, or maybe in forms of primitive data types, or even your data may be in forms of objects, okay, objects. Similarly, when you output, you're going to output data, okay, also you're going to output data. And your data again may be in forms of bytes, which is just bytes of what we don't know, okay, just bytes. Or maybe in forms of bytes representing ASCII letters, or maybe in forms of bytes representing Unicode letters, or maybe in forms of bytes representing some primitive data types. Okay, so this time we're going to study about input and outputs. Okay, and the input of the data may be coming from different sources. Okay, let's say it may come from keyboard. It's called standard inputs. Standard inputs. Let's say from your keyboard, system inputs, which is system.in. Okay, system.in. Okay, your data may be coming from a file inside your hard disk. Okay, okay. Your data may be coming from a network. Okay. Similarly, your data may be written out to corresponding components, maybe to network, maybe to file, maybe to system.out. okay, system.out or standard output, so on and so forth, okay, like system.out, like var again, and like the network again. Okay, this one is output. That's why in order to represent this one, there is a concept inside Java which is called a stream. Okay, which is called a stream. Okay, stream. So what is a stream? A stream is defined this way. Stream is an object. Okay, our Java applications, okay, can read or write data in form of sequence of bytes. Your data is sequence of bytes that I explained. Okay, from read or write, from or to. Okay, read data from or write data to. Okay, or it is a channel. Okay, in which our data is Java, our data Java. Okay, our data Java. Let's say Java from source to destination. Let's just give an example or something like this. Now we have this one. This is one of the example. This one is in our RAM, and our Java application is working with RAM. Okay, and this underneath here is our hard disk. Okay, and we have a file inside this hard disk. Have a file inside this hard disk, and this file of course is storing data, and your data is in forms of sequence of bytes 1001, so on, so like that. Okay, inside the data here you have sequence of bytes. Okay, sequence of bytes, each one of these 1 byte, 2 bytes, so on, so forth, sequence of bytes. Okay, then in our application, we would like to work with this sequence of bytes. We would like to read this sequence of bytes. So we're going to open an object which is called a stream. Okay, it's just like a pipe. And from this pipe, we're going to read this sequence of bytes in, like 1 0 1 1 0 1 1 1, so on and so forth, in our application. Okay. This one is called a stream. This one is called stream. Stream is from which that we can read the data, and it is a channel to which your data is traversed from source to destination. Okay, and specifically this case is you are reading data into your application, so that's why it's called input stream. Input stream. This one is input stream. Okay, and similarly, you can write the data after reading this data. You manipulate it into 1 1 1 0 1 1 1, so on and so forth. Okay, other sequence of bytes. Okay, and you would like to write this data down to another file. You would like to write this data down to another file. Okay, you're going to open another pipe, or you're going to open another stream, so that your data can travel from your application to the hard disk. Okay, to the hard disk. So it's going to be stored inside the hard disk. And this object is called a stream, and in this case, it's called an output stream. Okay, in this case, it's called an output stream. And now Java is object-oriented programming. That's why you have an input stream here. Okay, you have an input stream here, and you have an output stream here. Java will provide you two corresponding classes. Okay, two corresponding classes representing those streams. Sorry, this one is destination. Okay, representing those streams. So Java will provide you a class which is called an abstract class, which is called input stream, which is used to represent the stream from which you could read the data from. Okay, and another one is output stream. This one is used to represent the stream to which you are going to write data to. Okay, you're going to write data to. That one is the input stream and output stream, and they are just abstract class. Okay, they are just abstract class. Why are just abstract class? The reason is in this specific example, it is we are reading the file from the file. So actually, we're going to have an implementation of this, which is called file input stream. Okay, file input stream. Okay, and this one as well. We are writing to the. We are writing to the. We are writing to the. We are writing to the what? We are writing to the file. That's why we have another implementation of this upstream abstract class, which is file upstream. Okay, file input stream and file output stream. The reason of this, it is abstract class, as again is can be used for the input stream and the output stream classes can be used for many different sources or destinations types like network, file, then system or standards. Okay, so on and so forth. Okay, depends on, but specifically, if we use for file, let's say it has its own implementation for file. Okay, for file, that one is file input stream. Okay, but the input stream and the output stream classes are just generic for all the types. So what's that one for? So if you learn input stream and you learn output stream, you can use it for almost different types of sources. So it's like from network, from file, from systems. Okay, that is the meaning why. Okay, so similarly, you're going to have file input stream and also file output stream there. If you would like to work with parts, okay. That one is pretty much it about the theories. In next lecture, I'm going to in next slides, in next videos, I'm going to explain about the. I'm going to write demos about this one.